Hello everyone, my name is Akshay and today I'll be giving a small lecture on the topic called Internet of Things. I'll be dealing with how the Internet of Things and smart services has changed and changed in the society. Generally, Internet of Things is considered a disruptive technology trend that redefines the way we do business, produce and consume, communicate and work. Today's lecture can be categorized into two parts. One is the social perspective that deals with key trends and terms, smart services, effects on society, etc. The other part deals with the business perspective with subtopics like key trends and terms, enabling technologies, the challenges and opportunities for business, etc. So, so these are the topics as I've said you. The first is the social perspective and next is the business perspective. So moving on, the key trends and terms of social perspective include the Industry 4.0, which is applying the concept of cyber-physical systems to the manufacturing areas, and we equip people in the factory floor with digital services, digital devices that could be tablets and can be other things like smart glasses, etc. because these are considered as an augmented operator. So you can see a picture which a human is all connected to mobile devices, Bluetooth, which is nothing but a hands-free format or other wearables that communicate with the internet via voice commands. And there's one more wearable technology which is nothing but an optic head-mounted display, augmented reality devices, and the other is human machine cooperation assistance. So there are four phases for industrialization. The first phase, it started in the end of 18th century, which is the usage of water and steam power to run mechanical production facilities. It started from there, and the second phase begin in the 20th century, which makes use of electrical power to enable work sharing mass production. And the next was in the early 1970s, use of electronics and IT to automate production. And the final one, which we are using presently, is use of cyber-physical systems to monitor, analyze, and automate business. So the key trends in terms of social perspective also deals with the cyber-physical system, which is very technical. And at that time, many people were tuning around and talking about the Industry 3.0, which had many flaws, which led to the creation of Industry 4.0. So as I said you, it starts with the usage of embedded mini computers used by different appliances in our daily life. We generally try to merge the real world with the cyber world. When it comes to the mobile communication, we can measure the vibrations, temperatures by making use of the sensors. The only thing which is missing is, you see, Internet of Things is nothing but the internet address and the IP address, and we have enough of those, and therefore you come up with the connected cyber physical systems which extends the internet of real world. Some people speak about cyber physical production systems, but this is not all. At the end of the day, we have to look to the entire factory center. In the smart factory, we have smart products, and which means that the products know how to be manufactured. For example, we sometimes say the product tells the machine how it wants to be treated. We have smart and intelligent machine lead, hence they negotiate with each other who has free capacity. In addition, they collaborate machines and people, and sometimes people have said that collaborate like in a social network. That is the starting point of Industry 4.0, and the key concepts include integration in 3 dimensions, that is integration in dynamic ecosystem for business process, and also importance of vertical integration, where we combine the business process. Finally, and importantly, when it comes to engineering, we need seamless engineering as well. It started originally in 2006. We had first IT summit from the German government, and which it started originally in 2006. And we can imagine, if we have such an event for the first time, a lot of topics come out, and topics like open platforms for networks introduced, which also includes the business networks for business webs, which are considered to be popular these days, and also the social networks. Moreover, at the end of the summit, people agreed on 3 lighthouse projects, and the first was Internet of Things, since it was the famous at the time, coming from the RFID technology. Then other thoughts was about the SOA, which is nothing but the service oriented architecture, which was very popular in early days, which needs Internet of Services because we can combine digital services, let's say value adding services. So the second project considered was Internet of Services. The third project was an application called Smart Grid, also called as Internet of Energy. A research gen on cyber physical system, like what really it is what it has to do, And obviously, cyber-physical system play an important role in every area like Internet of Energy, which is important for smart grids, plays a role in health science, that is smart health. So let's see the next thing in social perspective, which is nothing but the smart services. So smart services simplifies the human effort, and global mathematical communities working to improve optimization techniques and services that get smarter. And we apply all the big data concepts that end up with smart services, converting big data to smart data. There's a picture you can see where the problems of the industrial partners and the algorithm expertise and the solutions for industrial partners were converted from big data into smart data using the global science community. So moving on, industries have established working groups for smart services in order to include other sectors. So it starts from media and ends in production. It can be logistics, it can be energy, it can be health, sale, etc. Some of the smart services industry examples are shown in the presentation. Few examples like manufacturing, which was included in Industry 4.2, and other energy levels like the smart grid, which was dynamic pricing, increased in efficiency, and other virtual plants. And when you consider the logistics, smart trucks, smart pictures come into the picture. And when you move on, there's one more, healthcare, which is a very important one, where the personalized and the patient-centric are characterized. And next is the agriculture, where the smart farming is involved, which deals with monitoring how the weather and the soil conditions for optimum point of harvesting. So some of the disruptive business models are also seen. You can take the example of the patient-centric health provision and prevention, and you can see a world of smart devices is emerging, and smart lenses which deals with the continued glucose monitoring via sensors built into contact lenses, and individualized real-time insulin provision, and also optimized nutrition. If you consider our normal apps like smart fitness tracking, we use it daily purpose to see how many calories have been reduced and all. Everything comes under the Internet of Things. And this fitness app support the achievement of athletic goals and motivate the user and the collection of personal activity patterns. Moving on, the smart services. If we start with the concept of smart services, if we look back, there is an old idea of business model innovation, and 10 years ago, let's say we promoted some of these concepts and everybody knows the famous examples that people say. At the end, the idea is to say, okay, we can provide personalized services to the individual. Let's say the fulfill his needs in his different worlds. We could be an employee, consumer, a citizen, a patient, etc. Exactly what we need in this specific world. This is to some extent an old idea, but what it was missing in the past to have enough knowledge about us and our demand, etc. So moreover, in the last years was the big data and converting big data. Big data generally deals with knowledge. If we consider an example, if we look to traditional ERP systems, 20 to 30 years was really into integration, which included integrated to product complaining, integrated to costing, but today we can do much more. We can take all the technical data where we find patterns and can be much more predictive, and we can find correlations like, let's say, if there is a certain vibration pattern, then we know from the experience that in 95% likelihood the machine will go down in the next 25 hours. So therefore this is prediction. Even more, we can be prescriptive. We can look to a big database, which is machine learning, where we have collected all the experience of the past, and then we look automatically if we find more less the same situation, and then we believe, okay, now we can apply the same action as the same, and we offer these actions to the people to get ready. Let's say some scenarios like what they should be doing, and if you do all the things I see, we can convert a classic plant maintenance to a smart plant maintenance services. So let us consider the second example. There is a company, a small startup, was founded by mathematicians, world-leading mathematicians, who know how to optimize things very complex. And now on the other side, now we have companies like, let's say, companies that manage big networks like network of gas or electricity. These companies have huge data, have experienced people, but say no mathematicians, and they don't know this optimization techniques. So what they do is they come up with a lot of real data, and some experienced people choose as mathematicians, and these mathematicians ask questions, and then they apply the best mathematical knowledge in order to convert the big data into the smart data. Sometimes into apply best mathematical knowledge, the software that helps the companies, they go a step forward. Viewing the exercise, they find out that what they know worldwide, what's best mathematical knowledge is, might not be good enough to the reality and say publish, let us say, this mathematical questions to the global community. Let us assume which industries and which sectors would benefit from smart services that we have described earlier. At the end, every industry and sector, that is the reason there was the launching of Industry 4.2 recommendations. Let us consider health scale example. In the past, its traditional business model that the pharma industries was selling pills, drugs to us. This is not the future, everybody knows. The smart devices which measure our vital data, measure of our fitness, and at the end of the day, people try to avoid that we get sick and need pills. So it's kind of shift to a business more of a traditional pharma industry from producing pills and selling drugs to us. Let's say to be more the coach in giving smart devices and smart services to us, which basically describes how the business is changing. So let us talk about how it is affecting us as consumers. Consumer, we can see two areas. One is pretty simple example. If you look back in early days, around 90s or 2000, smart vending machine was used. Very old and interesting example. In the meantime, if you look through a smart household, a good example people were showing is so-called connected kitchen. Means we are sitting far from kitchen and watching television, and there is a certain recipe which involves complex cooking, and we try, let's say, to copy this. In the past, we used to write it down 4 times. In the meantime, we can transfer the data directly to the equipment of the kitchen, and more or less it's like cooking automatically, putting all the technical data. Coming to another example like fitness program, which tells us that today we have to do a little more bit exercise because yesterday we ate too much. So this comes more to the consumer. They basically assemble everything for us. So let's move on to the next topic in social perspective, which is effects on society. So IoT gives manufacturers the ability to track objects, to find out how consumers are using a certain product, and to determine which features are the prominent ones. Everyday technologies based on IoT make factories smarter, safer, and more environmentally sustainable. So people have to expect that the content of the work will be changed more frequently. There will be a big shift in the tasks that people have to do. The smart factory is not free of humans. There is a greater scope for employee participation and decision making. So few of the blue collar production workers, more with white collar jobs, for example, system planning, engineering, integration into existing landscapes, performing tasks that cannot be automated, coordination and orchestration. Network, interdisciplinary working environment, wider variety of tasks performed by individual employees, shorter induction and learning periods, and few machine operators, more experts and more decision makers. Fewer prescribed ways of working, more autonomy. Lifelong learning, flexible management of work, content and working time. So data in the Internet things is automatically being exchanged between the systems and people. The security, data protection, privacy are considered challenges to be solved, otherwise they will not rely. You can see a picture which tells that personalized learning based on augmented reality technologies, which includes the industrial environment, the tools. It's all connected with an industrial worker with an augmented reality glasses, where the mobile interactive and situation aware tutoring is cope up. So, as I've said you, the value for business was good and flexible was much higher. And the Industry 4.2 makes use of much less resources, save energy because we put all this smartness and less mistakes and less waste. So all the things will be better and people understand this. We can bring production near to the urban environment so that the computing time will be less for the people. Moreover, the promise was to choose for better work because we can use this flexibility in promising the people that they can create an availability calendar. It gets the chance for the people to decide when you can work, when you want to work, and this is more or less, let us say, optimize together machines into a smart factory, which give the people better work-life balance and a lot of promises to society. So it starts from the data. There's no particular rules in the entire world for the topic data protection. It starts from who owns the data. Think about a car. Today's cars are smart ready. They collect many data and they get to know others' data also. Do they allow getting to know the others' data? No. But if you ask a car manufacturer, what do you think, who owns the data? It's the driver or the user. So it will be the first question if you collect more and more data in a smarter car, which our data, let's say primitive repair and maintenance, and car collects everything and knows exactly what you're driving, where you're driving, and how fast you're driving. So biggest concern is if we have an accident, then this car is so smart in the meantime, let us say automatically looks for help. On the other side, think about if it records everything and there is an accident and the judge asks you what you have done, and then it's like a black box, then takes the black box out of the car and can see what has happened. The second point after the data protection that can be considered is the privacy. The many different cultures, let's say in Europe, we have more concerns when compared to US, and we have to educate the public that privacy is important. But on the other side, it's helpful for the society if people allow some of the private data we used. Consider health scale again. We know people want to keep it private, but if you can collect all diagnosis, etc., we can be much better, let's say saving life of the other people. So here we have to find ways to protect the individuals but free up this data for the use of the society. And the final point is legally we need something like single data market, because otherwise we are too small as countries, we have to scale up quickly. So will we need humans in factories anymore? It's a very big question. So some people recollected the experience of the 80s. There was a similar concept called computer integrated manufacturing, and the promise of computer integrated manufacturing was the people-less factory, but we can't make it true. It's very clear that there will be more automated, so everything which can be standardized, future will be automated. On the other side, the demand for flexibility is much higher. Machines cannot do everything. Humans are better, we insist. So we need more working in teams, more decision making. Now the question comes up, what does this mean with learning? Can people live up to that? And again, technology can help. So we can provide personalized learning to you, which makes it much easier. Think again to smart glasses, where nearly every craftsman today could repair in a household just by producing the instructions into the smart glasses. So these are the things we promote. We know we have to do a lot around it, but I think it gives people a feeling it'll be more interesting work, it'll have more teamwork. Experience will be important. However, on the other side, we need different skills. So that means from the education system, we need flexibility as well, because self-organization is important. Lifelong learning, a little bit understanding for complex systems, for integration, a kind of understanding of disciplines that we are not educated in. We need more communication skills, let's say more social soft skills, because teamwork is important. Might be working also in teams of people who are not from your company, etc. So therefore, today the biggest concern is our educational system is not flexible enough. So in the next years, we can adapt our education system to produce these skills for the people who need in the smart factory. Two things must be considered to change the education system for the future, and the other is to upskill today's workers. So if you ask me like who owns all the moving data, it is considered as a big question. Most of the moving is taken care by the industry leaders, and they define this. The biggest difficulty in internet is global medium. If you consider what happens to the data that is moving constantly through the internet, people are extremely concerned from the business side, and this is not the flowing data. And there is a huge concern that this knowledge, which is a key knowledge for small companies, cannot be protected any longer. So we have to find ways, let's say, to make machines smarter. There are many more ideas about data encryption and end-to-end encryption to some extent. Technology is available about 90%, but not used. So if you consider what we are doing now to ensure the data is safe, right now most of the data and clouds, and coming back to the smart factory, the question is where this intelligence is. Smarter solutions include the identification of the product and keep the virtual presentation of the product into cloud, where we collect all this data. It's more or less like digital representation of the world. We can navigate, simulate, etc. Now we have two options. First say this is my private cloud and it is protected, and many people try to apply this or find trusted cloud to provide us. I think it's good business model for large companies to use trusted cloud provider. In addition, here we come back to the same questions like electronic marketplaces, loss of platform markets. So let's see how the challenges and opportunities for the society are present. So manipulating hardware is considered hard when compared to software, and the Internet of Things, data and services will be the key infrastructure of the next industrial revolution. And the digital convergence of industries will display the boundary between the industrial and service economy as everything as a service. And new data-based and consumer-oriented business models create both opportunities and challenges. So, we talked about challenges of data security and privacy, challenges to education and changing the way the workforce not only learns but also works. In addition to the challenges, we have one more challenge, that is complexity. People's general question includes about complexity, like can we manage complexity, because if everything is connected, first of all, if something breaks down in the connectivity, we doesn't know what happens to its domino effect. Think about the banking system, that's the first thing. The second is, now it's more virtual. The more we consider from hardware to software, the more vulnerability we can find. From the point of view, there will be even more critical infrastructure. If we consider the smart grid, all of a sudden we can manipulate the energy consumption. The main idea here is, can we reboot the critical infrastructure? I think there is a sense of emergency really about business and model innovation. We speak a lot about Industry 4.0 and people think it is about production, but it is not. Every company should immediately reconsider its existing business modeling and ask themselves that if their products, if the products are very smart, if they can at least connect to the internet, if they collect already real data, if they can make use of this data, if they can use the product and smart services platform, they need to immediately, because all big global companies are doing it already, to help their own small companies to survive in the market. So this ends the social perspective topic, and moving on to the business perspective, first we'll consider the key trends and terms. The key trends and terms deals with the Internet of Things. There is a massive opportunity to really understand the consumer and the end user, and the availability of digital information, something which is really transforming companies in terms of opportunities for growth. Now, reaching the end user with services, you can see a graph where the x-axis deals with the Internet of Things and the maturity level, and the y-axis deals with the added value for the company. And there's a constant growth from the connect product to the transform process, and then to the reimagined business by delivering new connected services. So we are in the process of enhancing and maybe transforming the physical world, which exists for years, into the digital world. I'm very much sure that future leaders in any industry will have the digital information as a core part of the business. So on the other side, companies who are not able to combine business model, combine technology, combine understanding of products and consumers will have a hard time, I would say, even to stay in the business in the future. If you see a figure over there which does the predict malfunction of products and provide new services, it deals with sense, monitor, analyze, predict, and act. Sense is nothing but a remotely sense operational data from equipment, and monitor, analyze, predict deals with the analyze and monitor equipment data and correlate with business information to predict the future malfunctions. And the act deals with the action of optimizing maintenance and service operations and enable new business models around the equipment. So if we consider how the Internet of Things and Industry 4.0 will affect society, and how is increasing digitization and networks affecting them, I think we heard a lot about the impact of digital information on the economy, on business, on companies, and then ultimately on complete industries. And may say this is a hype. However, if you look at reality, and when we really talk to customers, their vision has been transformed into reality, which means that the IT was always an enabler for business. So what does it mean as a concrete example? Let's take manufacturing industries. In the first way of leveraging information technology, they introduced information technology systems simply to support and to make the business process. Whether these information technology systems simply to support and to make the business process, whether these are supporting business processes like in HR, recruiting of people, payroll, or in finance to make a balance sheet, or whether this is the core process, like really controlling, steering the assembly and the manufacturing of products, making these processes to a massive extent supported and automated by the IT systems in order to have that established in the most efficient way. In the second wave, with the capabilities of the Internet of Connectivity, this has passed the boundaries of a company and was extended to company connection, but it was still that when a product left the company, these manufacturing companies, whatever they produce, did not have a direct interaction via the product with the real user. The better we understand the customer and the end user, the better can fulfill his needs. And this drives a transformation in terms of not just delivering a product, delivering a service where either the product is a part of the service And we see this already today happening, most obviously in the music industry if you consider, where the number of physical DVDs bought by consumers, sold by retailers is massively reducing. And while the availability of libraries and technically the streaming capabilities to consume music wherever you are, if you are at home in your living room or if you are in the car, is the way to go, is what is more and more penetrated. Why? It's because that service gives people the ultimate choice. You do not have to carry a DVD with you. In business, this will happen in the same order of magnitude. Into a virtual world where we even have the capability now with 3D printing to simulate and maybe ultimately to build products with a much higher efficiency than we have been able in the past. The Internet of Things is considered a disruptive trend and disruptive towards companies as well. While in the past it was the product itself with all the characteristics, you can take a leader in the industry who is the technology leader, who understands the business best, didn't have the chance to enhance their understanding with information from his own company, from the customer, but well, from the whole ecosystem. And if you combine the information which is available in the digital format, that disruption is possible. I don't say that it will happen automatically. You have to create awareness, you have to educate society, you have to educate your customers, and only if the new business model, if the disruption will happen. If it is perceived as a technology hype, if it's perceived as we want to do something crazy, then it will not create a disruption in terms of changing the behavior of people or changing the way of life. So let's move on to the smart software for smart services, which deals with the business perspective. Again, the sensor itself and the product need to have the ability to connect networks, and we need an open platform that allows companies to join with the industry competence, that allows companies to bring in the industrial experience. And building blocks of the Internet of Things, you can see the building blocks are nothing but the sensors, connectivity, device management, monitoring a life cycle, open integration and application platforms, applications on big data analytics, mobile user access, etc. So IT is going to make a big difference to growth and competitive advantage. Enterprise software is an ingredient since decades that helps to make companies competitive. You can see a picture which tells the business value of predictive maintenance, which is seen into two views. One is the operator view, one is the manufacturer view. Operator view deals with higher overall equipment effectiveness, improve maintenance efficiency, etc. And manufacturer view deals with the improving service profitability with low service costs and new revenue streams. And also it has higher first visit fixed rate, and also enable new inventions for the business models. And as I've said you, if we consider which technologies and building blocks are actually needed to drive information technology, we can say it is important that everybody understands when we talk about Internet of Things, Industrial Revolution 4.0, this is not just one technology, it is a huge set of technologies which are available now at reasonable prices, which are available at prices that allow massive scale. And if you go through that, it needs the ability that products have sensors that capture all kinds of parameters from the product itself. So whether this is a local area network or whether this is a wide area network does not matter. Then you need the bandwidth itself, and we have in the meantime bandwidth available prices that makes all that possible. In the past, it was library of books and you could go into a room. And now it's a library of digital information which requires a platform that is not only able to store the information, a platform that has the capability to digest that information and transform huge amount of data into in some cases petabytes of data into smart data. And if we would dream that this is one platform on the planet, it would be a dream and would never be successful. And as well, not like in the past, just on paper, again in terms of algorithms, in terms of software, in a digital format, then you need to bring that information to the decision makers who are mobile, who are connected, and you need to support a variety of devices, whether it is a smartphone, whether it is a tablet, and you make decisions or machines make decisions. Moreover, they have to be perfectly embedded and integrated into running operational systems that ultimately control the manufacturing process, that control the financial process. And that connectivity is something which is make or break. Partners who have been in the IT communities for a long time, but as well partners who have been in one of the industries, a leading partner for us for years. So moving on, coming to my favorite smart connected product, it is what I call predictive maintenance, that we are permanently connected with products. that we understand how a machine is running and we can offer a service before the product fails. So if you drive a car in the near future, it will happen that the car will not break anymore, that you get the information that a part needs to be exchanged prior to the car breaking. This is an experience everybody would love to have, and not just in cars, as well in commodity products and fridges, in water pumps. And this is not the basics everybody. This is like the basics everybody needs, and I would say every businesses as well appreciates, as this is a new level of capability where this predictive maintenance, this predictive service as a permanent monitoring of the condition, allowing real fulfilling the desire of the end users. So let us consider how is enterprise software going to help with the competitive advantage for customers and companies. Well, in the past, it was a supporting system, it was an enabler. In the future, software algorithms are the driver for innovation, and innovation itself is the driver for business growth. Moving on to the next topic, which is the enabling technologies. Now, the software means a variety of technologies which can be included the big data, the cloud, the mobile, etc. And there are essential elements like cloud, data centers, which allow you to connect people, which allows you to connect products. Energy is an asset which is scarce, which is increasing price, but which we all have to care about. So moving on to the next slide, the challenges and opportunities for business. Companies now have to understand that being a market leader in the industry with the existing technology will not be enough in order to be successful in the future. Companies need to try out which business models do work and which business model doesn't work. So if you see a picture out there which tells that reimagine your customer's experience, which includes things like innovative new business models, value-added services, and customer responsive products. And as I said, we make the Internet of Things sound like an exciting advance for companies and for society. What do companies have to do now to bring the Internet of Things to full potential for themselves and for their ecosystem, their partners, and their employees? So number one, they have to be creative. They have to think of possible new business models, how they can incorporate digital information going forward in order to serve customers better, in order to offer services that include products already. Moreover, that awareness is key, and not just the awareness itself. And based on the experience with the companies, not all attempts immediately are successful, but in other attempts, if you have one successful product, there is creativity and a huge amount of knowledge that is building on the first project, which is making a difference already, and ultimately changing the way of companies produce, the way the supply chain is executed, and the way customers are served. But you need to start, and you need to accept that this is an iterative approach. So what we can predict for the near future of Internet of Things? We can predict that the Internet of Things will change not just the economies, it will change people's lives. And the challenge that will be that we are used to a society, to an economy. Here a lot of regulations, laws, and behaviors are documented, are all well understood, and to create as a new boundary conditions in terms of who owns the data, who is allowed to access the data. It is about security, it is about privacy. Therefore, this is a real industrial revolution. I would say almost to the extent when machines had been created, when electricity had been used in our daily life, and the digital information will have impact on any industry, will have impact on everybody on the planet, and will have impacts as well on the economical healthiness of a company and the economical healthiness of an industry and even of states. So we have all heard today how the Internet of Things is going to change society and how it is going to change business, and in fact our lives as well. We have come to an end of our lecture. Thank you so much for watching. I know I have certainly learned a lot, and I hope even you have gained knowledge regarding the topic IoT. Thank you.